Okay, we want to continue discussing induction, and this time I'm going to present the induction a little bit differently. So first, we need to decide for which values of n, 2 to the n is strictly less than n factorial. I'll remind you what n factorial is in a second, and then prove your claim using induction. So this is our exercise that we're going to use today to learn a little bit more about induction. In particular, it will help us to understand the base case a little bit better, because we'll see right away that this is not true in general. Let me just remind you what an n factorial is, right? So that's like n times n minus 1 times n minus 2 dot 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 times 3 times 2 times 1. So whatever n is, you just multiply all the whole numbers starting at n all the way down to 1. Okay. Well, what's important is to first note that it's not going to work for n equals 1, actually. So that would be a terrible base case. So if we look at n equals 1, we see that 2 to the 1 on the one side and 1 factorial on the other. 1 factorial is equal to 1, and 2 to the 1 is equal to 2. So that does not work. It's not less than. Okay, now let's look at n equals 2. On the one side, we're looking at 2 squared, which of course is equal to 4. And on the other side, we're looking at 2 factorial, which is equal to 2. So again, this is not true. All right, let's go to n equals 3. I mean, hopefully eventually, I mean, maybe it's never true, right? But that would be a weird exercise. But anyway, so 2 cubed is equal to 8, and 3 factorial is equal to 3 times 2 times 1, which is 6. So again, it's not, the thing is here, factorial grows very fast, but it doesn't, in the beginning, it starts off actually quite slow, at least compared to 2. It takes a little while for factorial to start to build up. And also the point is that we're taking powers of 2, but so far in the factorial, we haven't really gotten beyond numbers like 2. So it's going to take a little while. Let's see, maybe 4 is the time. So now we go 2 to the 4th, which is 16. And we look at 4 factorial, which is 4 times 3 times 2 times 1. And we notice we're still, let's see, no, is that right? So 6, 6, 12, 24. Okay, now we've passed over, right? So now this is true. So this is true. And let's just go one more to n equals 5. And so at n equals 5, 2 to the 5th is equal to 32. Now it should still hold, hopefully, if we have some hope of induction working here. So we got 5.3 times 2 times 1, and that's equal to 120. So now we see, we've far surpassed. Right? And the point is that one way to think about this is if you replaced 5 with a 2, 4 with a 2, 3 with a 2, 2 with a 2, and this guy with the 2, only one of them is going in the wrong direction in the comparison, which is this guy. But all the other ones, you're going down, replacing 5 with 2, right? So it's not surprising that this is a much bigger product, because the only number where you slightly went up is when you replaced 1 with 2, but all the other ones will compensate for that, right? Anyway, that's not a proof, but that is something to think about. And so the claim that we want to prove is that so claim, right? If n is a natural number and n is bigger than or equal to 4, then 2 to the n is less than n factorial, right? So that's what we're claiming, and that's what we're going to prove now. But notice we had to do a little bit of had to do a little investigation to figure that out, right? So now let's do the induction. All right, so here's the proof. So proof. Let n be a natural number, n bigger than equal to 4. We will proceed by induction. All right, so the base case now, well, the base case is n equals 4, right? We'll see some subtle examples later on, but a lot of times the base case is clear. In this case, we've stated it so that we hopefully see that the base case is 4, because that's where you have to start. All right, so we already checked it, but we should check it here again, right? So 2 to the 4th is equal to 16, and that's less than or equal to 4 factorial, which is equal to 24. So checks out. That alone says nothing about the about this general claim, but it does mean that we can start the induction off. And so now, in the inductive case, we want to assume 2 to the n is less than n factorial. So we can start at this rung, and we will show that we can step to the next rung in the ladder, which means that we will show that 2 to the m plus 1 power is less than m plus 1 factorial. Okay, so now, by applying the inductive hypothesis, so the inductive hypothesis is what we're assuming. So we're assuming 2 to the n is strictly less than n factorial. So by applying the inductive hypothesis, we find, well, we can do the following. So we can start with 2 to the m plus 1 and say, oh, well, that's just like 2 times 2 to the m, right? And so that's not the inductive hypothesis, that's just algebra. But now we see the inductive hypothesis because we see the 2 to the m. So, oh, okay, well, that's less than 2 times n factorial. All right. Well, now we should notice that since n is bigger than equal to 4, which this is going to seem silly, but I'm going to write it anyway, we see that m plus 1 is bigger than 5, which is also bigger than 2, and hence, so what we notice here is that 2 times n factorial is less than if I replace the 2 with a n plus 1. So m plus 1 times n factorial. Okay, perfect. But that's also equal to m plus 1 factorial, right? That's how m plus 1 factorial is defined. You first peel off the m plus 1, and what's remaining is the n factorial. So we see, maybe I'll put a star here and a double star here. We see by combining, just to make it really clear to the reader, by combining star with double star, we obtain that 2 to the m plus 1 is less than m plus 1 factorial by the principle of induction. Then this got a little ugly. By the principle of induction, the claim holds. And we're done with the proof. Okay, so that's another example of induction. We'll see several more to get more and more practice with this, and you'll do several exercises on the worksheets involving induction, some very, very simple extensions of the exercises, of the examples, and then some of them will be a little bit more of a stretch. Okay,